happy to host Sumit Roy from OUSD R&E. His keynote is titled Beyond 5G Network Customization for US DoD. A little bit about Sumit. Sumit is an IEEE fellow. He received his master's and PhD from the University of California, Santa Barbara, all in electrical and computer engineering. He served as integrated systems professor of electrical and computer engineering at the University of Washington, Seattle, where his research and technology transition interests included analysis and design for wireless communication and sensor network systems with an emphasis on 5G and beyond standards. He spent 2001 to 2003 at Intel Wireless Technology Labs as a senior researcher engaged in systems architecture and standards development for ultra-wideband systems and the next generation high-speed wireless LAN. He has been active in IEEE Communication Society in various roles and currently serves as the program lead for Innovate Beyond 5G for OUSD R&E Beyond 5G initiative.
Yeah, Dr. Roy, thank you for accepting our invitation as part of a busy schedule. You have been encouraging IEEE and overall community to ask NextG, so the floor is yours. Thank you.
So firstly, again, thanks to Ashutosh and the organizers of the NextG Summit. Sorry I couldn't be there in person. Hope it's going well. And best wishes to everyone, both in person and remote. Always hard to follow Ronaldo, but I'll try my best to talk on a bit of a different topic. Most of you know me in my academic incarnation, but for the last couple of years, think of me essentially as a program manager or a program director within the office. OUSD stands for the Office of the Undersecretary of Defense. So within the US DoD, the research and engineering arm is responsible, as I will talk to you, for low TRL, what we call in the DoD $6-2 funded sort of applied research and prototyping centric work on the topic of networking broadly. So we are actively exploring the use of 5G and actually beyond 5G or XG networks for the specific use of customizing them for DoD use cases. So I divided my talk into sort of three portions. Unlike most of the speakers today, I will not have the opportunity to talk on specific sort of research projects, although my program has a fairly extensive and growing portfolio of 5G and beyond 5G research. But what I will attempt to do is I will try to give in the beginning sort of a high-level appreciation of why 5G matters to the US DoD, and within that, situate or describe the initiative within which my program, the Innovate Beyond 5G, resides, and the initiative is called the 5G to XG initiative. Thereafter, I'll provide some details of some of the technology areas of thrust, and none of this is going to be a real surprise. I will describe some of the pillars that are sort of the important dimensions that we are pursuing, and some of them, particularly given Ronaldo's fascinating overview, you can just think of this this segment as DoD looking to consume in a way that suits DoD's use cases, the kind of features or technology technology features that commercial technology provides. And finally, in that spirit, I'll talk a little bit about how DoD is looking to both engage with commercial vendors. We have our own industrial base, which we call the defense industrial base. But increasingly, as it goes to as this topic relates to commercially produced technology, we are looking to both be a consumer, source from commercial, as well as in return influence commercial. So we are looking at not only we are funding research, we are looking at prototyping, as well as from a future-looking perspective, looking to influence, the next evolution of beyond 5G or 6G standards. So, having said that, let me sort of dive into the first, subtopic, which is, why does 5G or any G or XG matter to the US DoD? Or in which ways does it matter? And the first level answer, so as I said, my talk will be mostly sort of programmatic and strategic. And to the first level, it's simply because beyond 5G, as has already been amply mentioned, is critical from a national economy scale, and in particular to all the listed critical infrastructures, whether it's cloud computing, whether it's smart cities, or in manufacturing, autonomous vehicle, or applications to finance or medicine, and most importantly, perhaps to us, for defense applications, right? So, we are in the US DoD, we look at this very huge commercial base that is creating both the future consumer devices, the clients and the mobile clients or handheld devices or portable devices, as well as the network components, right? And the key thing, as has already again been emphasized, is that when we look forward to beyond 5G, the kind of network design that commercial cellular technology excels at, which is largely has been centered on connectivity from human to human, both as sources and consumers, will transition to a world in which you have increasingly non-human sources, whether it's sensors or intelligent or semi-intelligent machines, and we will increasingly have networks that are a mix of human to machine as well as machine to machine communications, right? So the notion of connectivity changes. And as that notion of connectivity changes, the design precepts or principles that we bring to this, I think Ronaldo mentioned, moving from simply, spectral efficiency or area efficiency, moving from just a sort of a unidimensional emphasis on network throughput to much more nuanced semantic uses or other quality of experience, we will now have to revisit when we look at the human-machine interface or machine-to-machine interfacing. And then to emphasize a very obvious but oft-repeated point, the key performance metrics, so the KPIs that commercial industry in its design, we always have, as we know as engineers, a set of metrics. Again, this was mentioned in the previous keynote, and we tend to highlight a few over the others. Throughput, for example. But we are increasingly coming to a point where other metrics, for various applications, notably latency or reliability, is trumping just the unidimensional emphasis on throughput. One, but more importantly, as these networks scale in density, as traffic scales in density, for DoD, dealing with scaling in a secure way is paramount. Or broadly, designing for resiliency, is paramount when we realize that there is no such thing as a hard or a totally secure system. So, DoD networks, which have to be, scaled, and which have to be certified for use as being secure or meeting security objectives, must operate in highly insecure, highly uncertain, very dynamic environments, must operate through, adversary actions. And so essentially, reiterating what I just said, the notion of the KPIs that we must highlight, these get reversed or changed vis-a-vis what normal commercial technology would design to. So, given that it makes sense that DoD must or the U.S. government broadly must partner with industry, understand what we call the commercial curve. what are the ROIs, what are the business cases that drive industry, and how that maps to the products from industry, which is, hardware, software, network architectures, the interfaces definitions for 5G to XG, as well as, the evolving standards. And after, an understanding of what commercial, the commercial world produces, we have to adopt to our concepts of operations, our concepts of network operations for DoD use cases. So exploit the features where it suits us in a dual use win-win sense, and then innovate where it is needed. For example, typically in mitigating vulnerabilities, operating through adversary impacts, as well as building resiliency into the networks, right? So in order to do this sort of so if you think of these as two worlds, the commercial world and the DoD world, and there is some sort of a priori boundary or separation, what we have to do is not just walk the line, but actually cross the line from both from both sides. Take commercial products and reverse engineer it for DoD needs, or engage our defense industrial base, to innovate, based on the knowledge and the very significant investment. At the end of the day, the investment by commercial industry will still, by an orders of magnitude, outstrip what any government, including the U.S. government, etc., or U.S. DoD will be able to invest. And so, take this sense of collaborative experimentation as sort of the best way forward. So given that, we need to work with industry, we cannot sit on the sidelines. I think this, what I'm going to talk to you next is to show how the U.S. government and U.S. DoD, particularly funded by, Congress, is looking to retrofit or adapt what commercial industry is providing, and then innovating off it, right? And the point that I would like to emphasize is that this is sort of new industrial policy from the U.S. government of being proactive in the evolution of this technology. So given that we all agree that any G evolution, simply in terms of maturing the technology, is roughly a decade. Like, for example, 2030 is the sort of the target date that we all accept broadly for the evolution from 5G to 6G. So any evolution of a G is about a decade, and you expect for ROI that technology to at least last for several decades, right? It makes sense for DoD to be involved early in the game, right? So, we have tried other approaches where we have let, essentially, private industry, commercial industry drive the ROI, the development and maturation of technology based on commercial, as has been, was mentioned, based on, presumed commercial drivers. Well, I think the U.S. government does have a role whereby it can intervene early, provide DoD or U.S. government incentives. At the end of the day, the U.S. government is also a player, at least in providing the use cases, providing the certainly some of the innovation enterprise and some of the funding for it. So the best time is to do this early. Okay. Having said that, let's talk about what is actually happening on the ground. So since fiscal year 20, based on funding from the government, the U.S. DoD is actually acquiring commercial-grade 5G capabilities and deploying this on select U.S. bases. All right. So this is the role of adopting, whatever the commercial technology that is being offered to us by the commercial, the public world, right? And the point is to use this technology, deploy it in bases, but deploy it for various DoD use cases, which I will, highlight in a minute, and experiment with this at scale. So treat the current state of 5G as offered by 5G network vendors as sort of a tabula rasa, as a baseline, right? DoD becomes like a tenant. So essentially, we are now talking about enterprise scale, DoD owned, but potentially right now third-party operated. And this, of course, brings an interesting question that, with the sort of features of 5G or beyond 5G in the future, is there a potential business model, or what is so-called the private enterprise model, where the DoD not only is the owner of the network, but ultimately may become, in part or in full, the operator also of these networks at enterprise scale. So DoD right now is sort of the tenant of these of these networks. But the point is that the DoD wishes to use this network not just for the regular sort of use of 5G, as defined by you and me as customers of MNOs, with our client devices, the ability to connect to a network and exchange information, get our data as consumers. But the focus here is on the DoD as tenants who want to use the network for DoD sort of what we call mission critical use cases, right? And therein lies the need for innovation, right? The DoD use cases, as I mentioned, will rank network resiliency, security, and aspects of KPIs such as reliability. Potentially in many use cases higher, or latency in some cases higher than just mere throughput, right? Particularly when we have adversary operations, or simply, as has already been mentioned, since all of wireless starts with access to spectrum, when we have to operate in very contested, congested, and environments, right? And so, given that this is the perspective with which DoD enters, initially as an adopter, but finally moving beyond adoption to adaptation and to active experimentation and prototyping, that's the role of the program that I lead, which is the Innovate. And as I said, we work with, as I will describe further, we work with commercial vendors in this innovation, from starting with 5G to going beyond 5G. So treat us as very interested users, initial users, prototype testers of the products that 5G will continue to put out in the marketplace, and then sort of as collaborators. Certainly, we wish to walk the same journey as you do when we are looking to support R&D, applied R&D, test, eval, prototype, as well as engaging in standards. So, in some sense, some of these roles are mimicking what private industry does, but we are doing this, from a U.S. government needs and roles perspective. And so, this slide is simply a pictorial way to capture this. We start with commercial wireless in the top left, and the generally it's just what we call mill wireless. And in so doing, the U.S. government, and particularly the U.S. DoD, has its own DoD acquisition, a 5G acquisition strategy, has a 5G implementation plan, has a plan for innovating beyond 5G, and clearly observing commercial standards, global standards, as well as consortia of national interests, whether these are through the MNOs and their vendor chains, the commercial sector, or the defense industrial bases. We seek to engage with all of them. So as you see that on the top right, I have listed several of the technologies which were talked about recently, or I'm sure are the themes of specific R&D or talks that have already happened or will happen. And many of these technologies, such as the role of MIMO in scaling networks, as well as in network densification. The role of as has been mentioned, the non-terrestrial segment, the great proliferation of LEOs, as well as UAVs or other high altitude terrestrial platforms, right, in supplementing terrestrial coverage as well as capacity. Multi-band, multi-RAT operation. We as in the DoD are agnostic to what 5G is. 5G just isn't sort of mobile cellular technology. Other technologies such as Wi-Fi 6, Wi-Fi 7, which is emerging, these are all part of the multi-band, multi-RAT sort of agnostic RAN technology agnostic operations. And clearly, the various vectors of network softwareization, disaggregation, the insertion of autonomy through, at various points in the network through AI, ML. These are all, significant components that we are tracking and actually adopting and testing. All right. So how are we doing this in my portfolio? So this is a bit of a bit of a deeper dive at the next level of granularity. We run projects where we engage with commercial vendors as well as we engage with our defense industrial base. And the point is to actually test and prototype this technology, at least at the low TRL levels, initially in labs, in DoD labs, and thereafter in proving grounds, where we are providing the opportunity for early, adaptation of commercial grade, technology. As we know, one of the key things from our experiences with 4G LTE, as we have sought to adopt it into DoD networks, and now, currently with 5G, there are significant gaps between the ever-increasing sets of desired features, which constitute the kind of R&D work that engages academia and other enterprise partners. There's significant gaps between what is present in the academic literature or in sort of at concept phase, and what actual vendors will actually deploy. And there are many examples of this, including, as I say, go back to the issue of network densification, how scaling in bandwidth, scaling in space with MIMO, what are the current limits, and so if you look at any of these technology segments, what vendors will actually deploy, right, in practice, vis-a-vis what exists as a wish list, either in R&D or even in the technology specifications put out by 3GPP, this gap is, a one of constant interest to us in DoD, because one of our key objectives is to understand the gap between what's in a specification and what actual vendors will put out. And this gap exists for various, for various reasons. The most obvious is that commercial vendors will respond to their presumed ROI in the short to medium term. And they will do their own racking and stacking, and will implement some features and leave others for later implementation, or perhaps will never see some of these features, will never see the light of day. And given the as I mentioned, that the DoD's ConOps, the concepts of operations, and DoD's use cases and the KPIs are a reordered set from vis-a-vis commercial. Those are sometimes simply those are the vectors that DoD would like to invest in. So we do that, as in this slide, by listening to our end users, who are ultimately the engineers in our services, in the research labs in the Army, the Air Force, the Navy, etc. Okay, and our commands. And based on the emerging use cases that the military networks will confront with our peer adversaries in scenarios that are predicted, we try to map those use cases to technology specifications. And then as we look at and I will sort of give you some examples in the next few slides as to what this process entails, as we understand the technology gaps between current, what commercial technology vendors provide, and what we may need in the near future to support these DoD ConOps, those are exactly where we want to invest our R&D or low TRL dollars.
You have about 5 minutes, Sumit.
Sure. So I will, I'll skip. This is an example of some of the investments that DoD has made, sort of in the background. Some of you may know that of a recent award called the NSF Rings Award, and my program contributed $6 million to the overall total of $35 million. We have several BAAs on key topics that actually have been mentioned, like dynamic spectrum management. And I emphasize it's this is sort of a systems approach to actual spectrum management. There have been a lot of work academically, but far less in terms of transitioning ideas to actual prototypes. For example, spectrum sharing. All right. Similarly, we have other BAs out there on other topics, such as distributed MIMO, the kind of concepts that Ronaldo again mentioned. That as networks densify, what are the feasible ways in which you can scale network performance? All right. So I will just quickly say that the three basic pillars that that's of interest to us. One is of course secure and resilient 5G. Second is obviously things always start with spectrum, and particularly for the DoD, spectrum in the mid-band, is a point of keen interest, largely because DoD is a significant incumbent in the 3 gigahertz band, which is up, which is one of the bands which is up for auctioning, as some of particularly in the US. And then finally, the ever-growing evolution of DoD MNA or tactical networks. So let me just sort of exemplify the kind of projects or investments that my program and broadly the initiative is engaged in. So first of all, we know that looking ahead to 5G or beyond 5G, let's look at the RAN infrastructure. We are going to go from this integrated vision on the left-hand side to a much more distributed, open, programmable, virtualized implementation of the RANs. So we will have radio units, we will have DUs, distributed units, we have CUs, and we have these new interfaces. Well, we know that various industry consortium like the Open RAN Alliance or the Small Cell Forum, etc., they have their take as to how they are going to implement this for various use cases. Well, in DoD, we also have needs that are significantly tracking this progression of open and virtualized RAN implementations. And here are some of the differences driven by DoD ConOps vis-a-vis what commercial may be interested in. So, as was mentioned, let's say, the current architecture, by MNOs literally has typically the RUs cabled or fibered up to the DU, as you would expect. Now, in most of, or in many, I wouldn't say most, but in many significant, DoD use cases, this is one of those scenarios where the front haul we will want to be wireless. So, the emerging scenario for DoD mobile ad hoc networks or MNAs is one in which is increasingly all wireless, that the RU to the DU connection is wireless. And moment if it is wireless, we absolutely have to worry about the resiliency of that loop. So, we are really interested in solutions in which, if there is a jammer, right, which is jamming the RU to DU wireless front haul, we would like recovery loops of the order of, tens of milliseconds. Similarly, okay, if the backhaul, or the mid-haul between DU to CU is similarly compromised, we would require, a recovery loop of the order of hundreds of milliseconds, right? And similarly, if, as we know that if there is a sort of a real-time RIC, which is in sort of a cloud, an edge cloud, and from there, there's a non-real-time RIC, which is, more of in a remote cloud. And again, these are all wireless. We would like recovery loops from adversarial action on the order of hundreds of milliseconds. So these are all sorts of use cases which are emerging, okay, that will require novel, sort of DoD-driven solutions. Same as this example. There's a significant interest driven, by autonomous, driving, sort of C cellular V2X. And, the mode 2, which is a device-to-device mode of cellular V2X, right now, there's not a strong commercial pull. Well, here's use cases from DoD, future ad hoc networks or MANEs, where we will have significant needs for adapting or contributing to this commercial CV2X technology. So particularly when DoD operates in many cases in out of coverage scenarios. So as you well know, in several sort of operating bases outside the US, but which are in populated centers, we are maybe using host nation network, but in many other scenarios we are out of coverage. That's precisely where the action is. And here these sort of network infrastructure, which is DoD's own rolled up private networks based on device to device, may will actually be the sort of technologies that will enable future MANE concepts. So again, these are areas in which the DoD is looking significantly at what is happening to say mode 2 side link in say release 18 and going forward in 3GPP. And then here's an example that these the architecture of a DoD MANE in which you may have a squad, small, think of it as a small bubble of say about 10 people or so connecting to a vehicle which may act as the access point or the local hub. And these local hubs, these vehicles actually interconnect through a side link interface like the PC5 as shown here. All right. Finally, I mentioned again, I won't belabor this, spectrum is of keen interest to DoD, largely because in the midband, DoD is an incumbent, and of course there's huge pressure to be, to release this spectrum, or at least perhaps hopefully share the spectrum with commercial users. As we look forward to, how midband frequencies in the 3 gigahertz band is going to be dispensed with by FCC working with NTIA. So again, looking at actual system implementations, taking inspirations from what happened with the AWS 3 band and with CBRS as a technology, looking at new modes, both in terms of network engineering, the network stack, as well as what we call the environmental sensing capability to allow DoD or US government incumbents to share the spectrum, both temporally, frequency, temporally and spatially with commercial 5G or beyond. 5G is continues to be of interest. Okay, and again, for those of you who are interested, please contact. We are working with our industry partners. This is an example of a submission on spectrum sharing. And this is always an interesting question. Whether spectrum sharing is something that should go to 3GPP or because it's one of those topics that sort of falls through the cracks of established SDOs. And so, but the need for sharing, particularly in these hot congested bands, is paramount and something that the DoD is certainly going to be a player in. Next slide. I mentioned that we are following the standards work, okay? And some of this, the top technologies I mentioned, say example, Sidelink, obviously, integrated access and backhaul for, extending coverage and actually routing, over a small local area with very ad hoc mobile terrestrial or non-terrestrial nodes. Again, the integration of non-terrestrial networks with terrestrial, non-3GPP, i.e. integration of say Wi-Fi 6 with cellular. These are all features that are talked about in 3GPP, are currently action items, work items, but they are yet to mature. And these are all sort of technologies that are of interest to us. And finally, I will just end by saying that, we work with commercial partners as well as consortia. As a matter of fact, the DoD is supportive of the National Spectrum Consortium. There are working groups and Sidelink that is of interest to us as non-terrestrial networks. We are also observers of the ATIS Next G Alliance, and we contribute, and we are looking to contribute. And with that, I will finish up and take any questions. Thank you.
Sure. Let's thank the speaker first. Very interesting presentation, Sumit. We have a question, maybe a couple of questions from the online. What are the directions for free space optical communications in DoD? You have any take on that?
Sure. So great question. So not directly in my portfolio, but as you know, a recent Space Force was set up within the US DoD. And, in the spirit of, for example, in the spirit of interconnecting or architecting a full non-terrestrial network segments, we anticipate, just like the terrestrial, it'll have multiple layers. So there's maybe a lower UAV tier, there's some high altitude platforms, and then there's going to be a satellite tier. And inter-satellite networks, free space optics is going to play a role, particularly as you mentioned, as you know, it's pretty obvious. Anywhere we go in the world, that the role of that a secure terrestrial tier for backhauling, a secure non-terrestrial layer, a resilient, secure, with adequate backhaul, capacity is of paramount importance to DoD. Over.
There is a question from the floor. Go ahead, please.
Hi, Sumit. Great talk. Thank you very much. So this is Reza from Florida Atlantic University. I'm a professor there and founder of PQ Secure Technologies. So my question is about how modernization to next generation of cryptography solutions, for example, post-quantum cryptography or quantum-resistant cryptography is happening. How is DoD is doing that? I know DARPA had, for example, OPS 5G going quantum-resistant cryptography stuff there, but how is DoD, I think, other divisions?
Yeah, so great question. So, the quantum is not strictly in my portfolio, but as you know, there are many other directorates within DoD. So there is a program director for quantum separately, as well as, various DARPA projects that are looking, both sort of at the cryptographic level at sort of link security. I think as you might know, much of the interest from the perspective of securitizing or enhancing security for 5G is to look at the vulnerabilities of 5G. So we come at it from the perspective of network security, starting from the link, looking at the RAN, and looking at the threat vectors for 5G and trying to, sort of iteratively improve. Of course, the US government and, mostly backed or inspired by DoD, is looking to push this concept of zero trust network. So, in the sense of looking at securitizing, looking at principles and architecture for securitizing DoD networks that are going to be qualified. Look at the zero trust network concepts that is, there's a NIST technical report that sort of lays out the architectural principle. So as I said, short answer is that the quantum is a separate sort of, directorate that I don't have direct interest in, but other aspects of security we are continuing to invest.
So yeah, I think there's a last question here. We wanted to, I think the question is somewhat related to the free space stuff you talked about before. The question related to satellite and UAV. What is DoD's priority on that?
Okay, I'm sorry, could you...
Satellite-based communication, satellite. Yeah. And,
so yeah,
UAV.
Yeah, so again, and so that's something I could talk to because I have in my portfolio. So, let's talk about, the roles of, say, UAV. As I said, architecturally, the non-terrestrial layer is of great interest to DoD, right? They form, various parts of a tiered architecture for, say, backhauling data for our troops on the ground, etc. And so we have a UAV, we are busy architecting a UAV layer, trying, UAV out as a relay, both, as a UE, for example, connecting disconnected 5G bubbles. In the future, we are looking to 5G enabled sort of, mobile based, aerial base stations and mounted on UAVs. Same with, high altitude platforms. And yeah, integrating, LEOs into this. As you would have read, the role of LEOs in providing backhaul coverage in conflict, is a very significant aspect for both US DoD and for military operations worldwide.